slide is that some parameters related to engine is being controlled with the help of what you call as ECU. And what is this ECU? So for instance, you can think of ECU like a brain. Like a brain. What the brain does. So suppose vehicle is coming in front of us and I am trying to cross the road. Now the signal goes to my brain. And the brain tells me either I have to stop or I have to run fast and cross the road. I have to go for hurry in order to escape the accident. Correct? That means I am taking some signals and processing that signal in my mind, in my brain, and giving some instruction to some organs of my body, like for in this particular instant my legs, either to run fast or go back. Similar is the role of ECU here. So what is ECU? ECU is a programming unit, electronic unit, which is going to control the system with the help of actuator. What is this actuator? Now, just now in the example what I have given, the actuator was my legs. My leg was the actuator, and the signal was given by the brain to my legs to either run fast or to go back. So accordingly, my legs behave, and either I decided to run fast or to go back. Whatever signals was given, accordingly the legs behave. In a similar manner, actuators will be behaving according to the ECU. But for ECU to take decision, what is required? Some signals are required. And for some signals, what is required? Some sensors are required. So some sensors has to be there. Now, in my case, what was the sensor? My eye was the sensor. Correct? I was the sensor. Because I detected that, my eyes detected that some vehicle is coming in front of me now. And there is a probability of accident. So the sensor was my eye, and the signal from the eyes goes to brain. And brain decides, now instead of crossing road, I have to go back. That means the brain decided to actuate the actuator, which is legs, to go back. And now the decision for crossing the road has been temporarily put aside. Now he is going back. I'm going back. So in a similar manner, we here also in automobiles we have so many sensors. And what is the role of the sensors? The detection of, instead of your engine, you can put as automobile. So concisely I am taking an engine as an example. That is why I have put this particular slide. So here detection of engine operating conditions or modes, and accordingly some signal was given to ECU. Now ECU will, what ECU has? It is an electronic unit which is being programmed. In the ECU there is a program. So what this program does? When the program gets some input values in form of signals, it processes that values and gives some output to the actuators. So now output actuator is in a position to decide what to do. Okay. So the role of the sensor is to take some signal and give it to ECU. ECU is going to process that particular data and give the signals out to the actuators, and actuators are going to actuate whatever is supposed to be done as per the requirement. Okay, so here we have written sensors for detection of the engine operating modes, electronic control which elaborates the signal value supplied by the sensor according to defined control strategies and algorithms and defines the action to be delivered to the actuator. An actuator which have the task to actuate the defined commands. So it is going to take some action. Okay. So now this thing is being proceeded here also. So in the same in this slide also it is same. What has been given on left side we have put all the sensors, and on the right side it has been mentioned what are the different actuators. Okay, so different sensors are this, different actuators are this. So if you can enlarge your screen, and let me check out whether I can. Okay, so here it is airflow meter. Here it is related to distributor, some engine position, signal, pulse signal, water temperature sensor, intake air temperature sensor, throttle position sensor, ignition switch sensor, vehicle speed sensor, then oxygen sensor, then you have a PGR gas temperature sensor, NOx sensor, uh, neutral start switch, uh, then you have a cruise control related sensors, so many things. So you can see all the sensors are there. So when all these particular sensors are going to sense something, they are going to give some data to ECU, and here it is mentioned what the data is being given. Okay, so airflow meter sensor gives the velocity. Here, this particular sensors give what is the CO value, what is the NOx value, what is the CO, that is carbon dioxide, or whatever values are there. So then water temperature meter gives some temperature. Then water intake air temperature, it also gives in form of temperature. So all those values are given to ECU. And for ECU, obviously power supply is required, a battery is connected, and ECU is going to decide something. It is the program, with the help of the program. Obviously, you know, you have done some programming in C++ or C or some languages and all. So what will be there when you do a certain program? It will ask for certain values, some data, input data. When input is given, some output will be there. So input values are those values which here given by the sensor, and output values are here. Here these are the output values. So accordingly it is going to take some decisions, and the decisions will be conveyed to particular sensor, actuators. Okay, so they may be related to engine, they may be related to EGR, exhaust gas recirculation, or it may be related to anything. It may be related to ignition advance, it may be related to speed control, it may be related to brakes, whatever it is there. So there are so many sensors. Nowadays, thousands of sensors are there in a vehicle. And correspondingly, for every major equipment to be controlled, there will be one EGR. So whatever data is required from this different sensor, that will be taken by that particular ECU, and accordingly what action needed is going to be that will be decided, and that will be information will be given to actuator. So that is the meaning of this particular slide. Then yeah, you have here this is ECU, something looks like. So here we have the ECU, and in this slide again a microprocessor is shown. So as I said, it is an electronic component. You can see it is an electronic component. Microprocessors, why it is required, and all these things have been explained by Sir. Used in automobiles, so some different microprocessors used in automobiles has been explained over here. Here in action, so it is here you can see the belt pressure, gear speed, vehicle speed, steering angle, gear position sensor, temperature sensor, accelerator sensor, and ignition sensor. These many sensors give information, and accordingly some solenoids, clutch, actuators, hydraulic pump, diurnal, all this will be controlled. Okay, so in order to control suppose It is not always necessary that one sensor is going to give data to only one ECU. Not necessary. It may give to multiple, because there will be so many ECUs which will be requiring the input as a engine speed. So that all ECU will be fed with the data of speed whichever is required for controlling a corresponding actuator. म्हणजे जो कुठला ऍक्च्युएटर कंट्रोल करायचा आहे त्याच्यासाठी जे कुठला पॅरामीटर्स लागणार आहे ते सगळं त्या ECU ला दिलं जाईल. And many times so many systems ECUs act in coordination. आणि या स्लाइड मध्ये जे काही सांगितलंय ते this particular ECUs are being categorized into 4 different categories. So the different categories are mentioned over here. So you can see over some body related things are there. So the parameters are there which need to be controlled, body related. Some powertrain related parameters are there which need to be controlled, that also will be controlled. Then some safety related controls will be need to be are there which need to be handled, that has to be again controlled. And some multimedia related systems are there that need to be controlled. So for example, body related, when you talk of there are some lights, then mirrors has to be turned out, etc. Then when we give the ignition key, etc., that has to be taken care. So all those things are need to be controlled. They are related to body related systems. And some power related system are there. So power related systems, we have the ABS, that means anti-lock braking system, then some transmission related parameters, then brake related, and engine controls like ignition, etc. So many parameters need to be controlled. And we have some safety related parameters which need to be controlled, like airbags and so many sensors or actuators like some warning lights, etc., etc. They are controlled. They comes under this particular safety related category. Then multimedia related category are there. Some we might have some video, audio, or some TV, something like for recreation and etc. Okay, or we have a car navigation system like GPS, etc. So all this comes under this. So generally, these are the 4 categories of the modern systems, different systems where we have different types of ECUs. Okay, so the category that has been categorized like this. So this is a category, 4 categories under which your different sensors and ECUs are going to fall. One of the example has been shown over here. So what are the example is to make you understand what actually how it is going to be done. Now here is a ECU, and this particular ignition ECU is ECU for combined ignition and fuel system. So it is a part of ignition also. It is a part of the fuel system also. Okay, so ECU now takes the engine speed. Here the engine load, here the temperature and the ambient temperature. So 2 temperature and 1 speed and 1 load. These are the parameters sensed. That means this many signals are going to ECU, and this particular 4 signals become a part of 2 control units. One is related to ignition control, where we want to advance the ignition or retard the ignition, or we have a fuel system where we want to decide when we are going to spray the fuel in the system, at what quantity, at what time, and what duration. Okay, and both these things are again related to engine, and then correspondingly we get out. So this is how ECU is going to work. So in order to ECU to decide whether the ignition has to be advanced or retarded, these signals are required for ignition to take care. Similarly, in order the fuel system to decide how much fuel is going to be sprayed at what time and what quantity, you need the signals from these many sensors. Okay, so some sensors are there which give some signals to ECU, and on the basis of that is signals, ECU is going to decide some action, and the actions are going to given to the actuators related to that particular system. For example, here the actuator related to advance mechanism will come into action, and it will go for advancing or retarding. Here, the mechanism related to injection system will come into action, and that injection system will decide how much fuel is going to be sprayed at what time and what quantity, etc., etc. And when these two systems actions are being combined, your engine is going to work in a proper manner to give the required output. So that is the meaning of this particular slide, whatever you are seeing on the screen, where you can see so many inputs coming, and on the basis of which you are going to take some decisions. So all the slides are same, one and the same. Here some list of, here also some sensors has been shown. So you can see the force sensor, brake sensor, throttle position sensor, accelerator, pedal position sensor, suspension control sensor, mass flow sensor, then manifold pressure sensor, air condition related sensor, fuel pressure sensor. See, you can see so many sensors related to different and their locations inside the systems as we here. Again, we have put just the names: crankcase position sensor, engine pump coolant temperature sensor. Now here, as an engineer, if you are fortunate enough and depending on your skill and your eligibility, it happens that you become a part of a company which is working on modern vehicles. Then you may come across some of these particular sensors. So what your duty should be here, it is not possible that for a chapter of 3-4 lecture weightage, we can discuss here all the sensors, what is their functions, what is how they are working, and so on and so on and so on. Okay, so there are, as I said, there are so many sensors, hundreds and hundreds of sensors in the vehicle nowadays. For every system, there will be so many sensors, and rather there are hundreds of ECUs, and for every ECU there are so many sensors. So you can think of number of sensors, okay, in a modern vehicle. So nowadays, a vehicle has become more electronic than mechanical. Even though the basic operation is mechanical, most of this control part is becoming electronically controlled, and that is where the role of sensors and actuators are coming into picture. So nowadays, you need to be a multidisciplinary. You cannot confine yourself that I am a mechanical engineer and I will only learn mechanical. No, this is not possible for nowadays. You have to be multidisciplinary. You should know, as a mechanical engineer, when you go in the company, you should know some electronics also. You should know some computer also. You should know electrical also. Everything you have to know, because there is nothing purely core business remaining nowadays. Everywhere you go, there will be some electronics, there will be some computer, there will be some mechanical, because every machine, if we are talking of its working part, is going to be a mechanical. Okay, but in order to control that particular working, some electronics will be required, and using that particular electronics nowadays, we want to make it more accurate and more efficient and faster, etc. And for that, the data input and etc. will be done with the help of computers. So if you want to be a part of such a system, then obviously you should know computer also, you should know electronic also, you should know electrical also, and you should know basically obviously mechanical also. Okay, so here are some of the sensors. Crankshaft position sensor. What is this crankshaft position sensor? So crankshaft position sensor is a sensor which tells the ECU that at what position is the crankshaft rotating crankshaft is. So by knowing the crankshaft position, now the ECU can decide in which cylinder the ignition is going to take place, or it should happen. Rather, in which cylinder now the compression is going to end and ignition has to happen. So in order to decide, ECU to decide in which cylinder ignition has to be given at a proper timing, you should know at what position the crankshaft is. So unless and until it does not know the position of the crankshaft, the ECU cannot decide at what timing the ignition can be given. Again, suppose the walls are supposed to be controlled electronically, wall operation. Then obviously what will be required? Again, we need to know where the piston is, because we want to say some degrees before TDC, piston reaches TDC, we are going to open some wall or close some wall. But in order how to understand that piston is some degrees before TDC, you cannot directly go to piston and directly check. So indirectly we are checking with the help of crankshaft. So by knowing where the crankshaft is, how much crankshaft has rotated from its zero position, we are trying to find out where the piston is inside the combustion chamber. And depending on where the piston is, we are going to decide what action is supposed to be taken. Okay, so this will be true with the valves, this will be true with the injection system, this will be true with the ignition system, and so on. Okay, so all the crankshaft position sensor will be given input to all these particular control systems. Now, similarly, engine coolant temperature sensor. What it gives? It gives the temperature of the engine. Now, what is used for? It will be used for knowing the temperature. But what is the use of the temperature? Knowing the temperature. So, first thing, if the temperature is high, it means the engine is not being cold started. बरोबर? आता engine start केलेलं नाहीये. Already engine अगोदर start केलेलं आहे, कारण आता temperature जास्त आहे. Means the fuel system will know that it is not cold starting. It is presently in a running condition. Because cold starting conditions are different and running conditions are different. Okay, so the fuel requirement in the cold starting will be, as you learned in IC engine, it will be rich. But in a cruising mode, we want a lean mixture. In a starting mode, we want a rich mixture. So if the fuel system has to decide whether the engine has to be supplied with a rich mixture or lean mixture, then the ECU has to know, ECU related to fuel system has to know whether the engine is presently in a starting mode or running cruising mode. So if it is in a cruising mode, then it will supply lean mixture. If it is in a starting mode, then it will supply with a rich mixture. And for that, what is required? Somehow it has to come to know that whether just you have started just the engine or not. So that will be coming to know with the help of engine temperature sensor. So if that engine temperature sensor is higher, engine temperature, now where the basically where you will be put that particular, it is in the engine coolant water which is coming out of the engine, that particular temperature sensor will be put. So if that particular water coming out of the engine is at higher temperature, it means engine is at a higher temperature. If the water coming out of the engine is at a very less temperature, it means engine is a cooler. There is no heat inside the engine. Correct. So on the basis of that, engine is going to decide something. Because condition to condition, the fuel supply need to be changed. Condition to condition, ignition system need to be advanced or retarded, and so on. Hall effect sensors are used to time the speed of the wheel and the shaft. So this particular Hall effect sensors are used to detect the speed of the. So for example, you have the crankshaft speed sensor. So you want to measure the what is the rotation of the crankshaft now. What is the rotational speed of the wheels now? So there you need to put this particular sensor. Then manifold absolute pressure sensor. So this will be generally used in the intake system, air intake system, intake manifold, where the air is coming in. Now what is the use of this particular sensor? Knowing what is the use of knowing the pressure in the intake manifold? It will tell if the pressure is less. If the pressure is less, the density is going to be less. That means there will be less oxygen in the air supplied to the cylinder. If the pressure is more, that means more air is coming, or density of air is more. That means more oxygen is going to be there in the air in the cylinder, which is being supplied to the engine. That means depending on the amount of air supplied, oxygen present inside the combustion chamber. Now the fuel system can decide how much fuel need to be sprayed, because if the air is less, oxygen availability is less, and if you are going to spray more fuel, that is not going to burn. And if your air is oxygen availability is more, and if you are spraying less fuel, that is underutilization of the system. Then why you are supplying more air? So decrease the air then. Okay, so in such manner this will be controlled. Oxygen sensor used in, to monitor amount of oxygen in the exhaust. What this will tell you? So here we are trying to measure whether there is oxygen in the gases coming as an outlet from the system. So if the sensor is detecting some oxygen in the exhaust, what is the meaning? The meaning is that the efficiency of the combustion taking place inside the engine is less. Some air is coming unutilized out of the engine cylinder. That is the meaning. So if some engine oxygen is coming out of the engine unutilized, means that that amount of oxygen has been wasted. It is not only that oxygen being wasted. In order to accommodate that much amount of oxygen, there was some amount of air, and you have done some compression work on that particular air. So that much work also has been wasted. So unnecessary your work has been wasted if oxygen is coming out unutilized from the cylinder. Okay, so that is where the need of the oxygen sensor comes into picture. Parking position sensor, you know, the obstacles in the parking. Speed sensor, you know. Throttle position sensor, used to monitor the position of the throttle. What is the throttle? Throttle is a valve which opens and closes the passage of the air as per requirement. Correct? So here you are talking of throttle position sensor. Now throttle position sensor will tell how much it is opened or closed. That indirectly it will tell how much air is going to come in or coming into the engine. So as I said in the previous case, if the oxygen coming out of the cylinder was more, and if you are requiring only very less amount of energy presently, then you why you are supplying extra air? Because when you supply extra air, extra work has to be done to compress it. So we have to decrease the air. Then the signal will go to this throttle to close it. But how much amount it has closed, whether it is open to required amount or not, that has to be verified. So the sensor is there to tell, yes, now it is open to this much amount only as per requirement. So whenever the requirement of air is more, it will be open. Whenever signal will go to actuator to open it more, and whenever the amount of air is less, signal will go to actuator to close it more. Okay. So like this, we have so many sensors. So one by one sensors you can take, and you can understand what are their functions, what is their relevance in the operation of the engine and the automobile, and so on. So see, till now whatever I have explained are related to engine, but it is not true. This is only not engine. When we say automobile, we do have powertrain related. So powertrain related systems, we have vehicle energy use, drivability, performance, all these particular applications are there. Chassis related parameters which need to be controlled are vehicle stability, safety, etc. Body related occupants needs are there. Okay, and here when powertrain related things which are supposed to be controlled, the elements included are engine, transmission, etc., etc. So here how much vehicle energy is required, whether the speed, drivability is better, if whether you are going for a harsh drive or a soft drive, whether the performance is better or poor. So all these things, and these are the engine related things, related components to this powertrain. Then we are talking of a chassis related, we have handling. Handling means whether the stability of the vehicle is better, whether there is a yaw, whether is a means why AWR? So we have different parameters related to stability of a vehicle. Okay, we have sideways motion, we have backward and frontward motion, that is lift, drag, and so on. Okay, so all this parameter will be coming under this vehicle stability, and things related to it are steering, suspension, brake, etc., etc. Then when we talk of body related things, then we are talking of occupant safety, security, comfort, convenience, and we have some informations. Okay, so these will be things. Here we are talking of automatic clutch. So you can see some signals given from this and some actuators working in collaboration with it, wherein we can again we have a in automatic clutch also there is ECU now you can see. So when till now whenever you think of a clutch you will be only imagining a mechanical device where one disc is there, another disc is there, they come into contact with each other and they transfer power from one unit to another and your mechanical clutch is over. But nowadays clutch is not over to that. Nowadays you are talking of automatic clutch and there is ECU. So the ECU is going to control so many parameters. So some hydraulic pressure is going to be applied in order for the axial thrust to be applied on the clutch. So in order to apply that particular axial thrust, this hydraulic system is coming into picture. Okay, then to release this particular springs, some mechanism is there. So whether it is coming into operation or not, and we require so many sensors input. So we have throttle, then we have accelerator pedal sensor, we have gear lever position sensor, we have gear load sensor, we have input shaft speed sensor, then the engine speed sensor, and so on. So many sensors giving input to this particular electronic unit, and correspondingly the clutch is going to operate. Okay, so you need to understand that also. So similarly, so many systems. I hope all this particular system might have been covered by sir. So here are some powertrain related sensors. So here powertrain related sensors are there are with respect to cylinder there is a pressure sensor and a combustion sensor. In the manifold we have a pressure and a temperature sensor. In the turbocharger we have a pressure sensor. In the engine again there is a NOx sensor. Then the air intake system we have a mass flow sensor. On the engine torque side, that is shaft side, we have so many sensors. Then the air fuel ratio for finding out the air fuel ratio, we have so many sensors. Then the exhaust gas, we have so many sensors. EGR, we have sensors. Crankshaft, camshaft, total pedal, fuel system. See this in the list of sensors, and all these related to powertrain. Okay, so these are powertrain train related sensors. And they are continued related to misfiring, related to catalytic converter, related to engine oil, related to cooling system, related to fuel tank. Then we have transmission related, that is CVT, continuous variable drive related, and so on. So what you have to understand from this is, see the number of sensors working, which will be telling you that today your role is not purely mechanical, remaining mechanical. And whenever earlier days when suppose a person is asked to being a mechanical engineer, somebody is asked to check out this is my vehicle, it is giving some problem. As a mechanical engineer, please tell me what is the problem. It was easy for a mechanical engineer to find out the problem knowing the mechanical basics. But nowadays it is not possible because everything is now electronics. So you cannot remain now purely mechanical. You have to be multidisciplinary, where you can see just now we have listed different sensors, and these many sensors are going to come into picture. Similarly for electronic fuel injection, and then here are some powertrain functions related to economy, emission, performance. Here related to economy and emissions, we have combustion related, then wall timing related, then we have gear shifting related, clutch related, etc., etc. Drivability related, we have so many categorized. We are categorizing the sensors into different categories, which will be helping in uh, controlling different parameters related to either safety, maneuverability, or handling, ride handling, etc., etc. So braking, steering, air condition, suspension, stability, and so on. So everything nowadays we will have sensors. Suspension, chassis related applications. So brakes, anti-lock braking, steering, so four-wheel steering, etc. Vehicle stability, suspension, tire pressure, tire temperature. So you can see, just see the list. So body related functions, crash avoidance, crash worthiness, advanced airbags, anti-theft, anti-intrusions, occupant sensors. So these are the modern systems. You can just think of this many systems wherein again there will be every thing will be requiring one ECU, so many sensors and some actuators, and your role as a mechanical engineer will be now to understand this particular electronics part, because you cannot remain now purely mechanical. So alarm system, a complex alarm system. So what are the different conditions and or what all things you need different alarms. So we have different size. See, door locking, we have system LED, hazard lights, ignition related warnings. Then so many warning systems are there, and they need to be operated, and they need to be have some sensors. So for example, here, if your IR key is not put properly, then it will give some signal. So like this, there are so many safety related sensors systems, and they will be requiring sensors and actuators. Body related applications, airbag, seat belt locking, seat occupancy. So more people are sitting in the vehicle, the signal will come to the driver that more occupants are sitting, and it is beyond the weight the carrying capacity of the vehicle. Okay. uh, then parking, blind spot, lane departure, night vision, all this again are so many applications related to in the modern vehicles, which need to be taken care by mechanical engineers. And here continued adaptive cruise control, lateral lane guidance, then we have navigation. So then we have a climate related. So if sun is there, if humidity is there, if rain is there, etc. Then air conditioning related, anti-theft related, anti-intrusion related. So anything. So you can see so many airbag electronics. So in order to operate airbag is very simple thing, isn't it? You may think that okay, whenever shock is there, whenever the accident is there, airbag is going to inflate. But in order to inflate, how much complex system is required? And as a mechanical engineer, you are supposed to understand this. So how many signals are required? And all those things has to be given to ECU, and ECU has to given to signal has to be come to a finally actuator to actuate, and then it will come into action. So the airbag electronic, it is a block diagram only, so it is so much complicated. It is not that easy, and that is why whenever we add this particular modern systems in the engine, sorry, in the vehicles, you might be seeing that the cost of the vehicle is increasing in some folds. On one hand, you have vehicles of 1 or 2 lakhs or 3 lakhs cost. On the other hand, you have vehicles in the cost range of some lakhs, like 20 lakh, 30 lakh, 40 lakh, and so on. Okay. Nowadays, there are some vehicles even in some crores also. So now why this particular increase in the cost? Because you can see, just imagine airbag. So when one airbag is added, these many things are going to be added into system. That means system is becoming that much complicated. And here we have hybrid system. Okay, hybrid vehicles. Sure, this is your conventional engine powered vehicle. So engine, transmission, drive given to wheels. But in hybrid vehicles, we have a series hybrid and a parallel hybrid. So what is a series hybrid and what is a parallel hybrid? So here you can see in a series hybrid, you have an engine, you have a generator, you have a battery, you have a motor. So means engine produces the power. Power is given to generator to generate the electricity, and electricity is given to battery to charge the battery. And as per requirement of the wheels, the battery power is taken from the battery to run the motor, and motor will drive the transmission and the wheels. So this is a series arrangement wherein engine is working, it is producing mechanical power, and using this particular mechanical power, you are running the generator, and the generator will charge the battery, and from the battery, the power electricity will be taken to run the motor, and the motor will be, you are now powering the transmission system as per requirement. So this is a series system. Here is a parallel flow system. So this is a parallel hybrid. This is a series hybrid. So this is in a parallel hybrid. You have an engine over here, and from engine, power directly goes to clutch and to the drive shaft. Simultaneously, you have a battery, you have a motor, and motor is operating, also giving powering the clutch, and the power is given. So simultaneously, engine and battery can give power to your transmission system, both. So here what we do is we run the engine at a particular minimum speed, optimum speed rather, and as and when this will be supplying power, whenever this particular whatever design power is more than the sorry, when the power required by the vehicle is more than the whatever is being supplied by the engine, at that time we will be taking power from this line also. If the power required by this is lesser than the whatever is being supplied by the engine, at that time it will be good to run the motor and it will charge the battery. So in that way it works. Okay, and here it is purely engine will be run at a particular speed, continuously running the generator. Generator will charge the battery continuously, and if it is fully charged, at that time engine will be given signal to stop, and it will be again started when battery starts discharging. So here whatever amount of the power required, as per that power the electricity will be taken, the motor will be run, and the power will be supplied to the wheels. Okay, so this is your series hybrid and a parallel hybrid type of arrangement of vehicles. So nowadays you are talking of so many hybrid vehicles, and you can see over here the hybrid electric cars. Then you have so different Honda Civic, Toyota Virus, then the Ford Escape, and so on. Now we are, I think, moving to the solar system. So we have a solar system. In a solar system, we have okay. Before that, we have some concept called as a regenerative braking. Now, in this particular regenerative braking, what we do is here we have some motors. Now, this aims at minimize the wastage of power which was supposed to be lost when the brakes are applied. So we know that when the vehicle is in motion and when we see some emergency, we apply the brakes. But presently the system is moving. The automobile system as a whole is moving with some energy. It is possessing some energy. It is having some momentum. And with that momentum, it is moving. Correct? And when we apply the brake, what happens? that kinetic energy possessed by the vehicle is being converted into heat and it is dissipated to atmosphere. That means it is going to be wasted. But our aim here is not to waste the energy. So whatever was supposed to be wasted, now can be it is regenerated, and that is where your regenerative braking system come into picture. That means the energy which was supposed to be wasted at the brake end can be regenerated or can be reused with the help of what is the principle of regeneration, where that instead of converting it into heat and dissipating into an atmosphere, what we do is we take that particular energy back to run a motor, and that motor will now charge the battery. So instead of converting the kinetic energy into heat energy, we will take that particular energy, we will couple the whenever brakes are applied, we will couple the wheels with the motor, and now motor will absorb that energy from the wheels, and instead of now converting the kinetic energy into heat and being wasted, now we are utilizing that particular kinetic energy to run the motor, and a motor is being now run to produce the electricity, and using that electricity battery is being charged. Okay, so this is the concept of regeneration. Okay, so here it is written, as the car brakes, the energy motion from the wheel is transferred to electric motor. The electric motor acts as a gearbox, generator, producing electricity. This electricity is sent to battery where it is stored. Okay, so this comes into action only when the brakes are applied. So this particular system, whatever we are talking of, is what we call as a regenerative braking. Okay, concept is called as regeneration, and the system is called as regenerative braking. Now moving ahead to components of a solar vehicle. So we do have so many solar vehicles nowadays, and we have solar array, power tracker, batteries, motors, motor controller. All these are the components of solar vehicles. So these are the how the solar arrays look like. So nowadays you might have seen the different vehicles, and you can see the solar arrays like this. The power tracker, because very important, because the sun is not always at the same position in the sky. So as the sun moves from east to west, from morning to evening, the power tracker has to direct the solar radiation on the solar array in such a manner that most of the energy will be utilized. So some power trackers will be required. Some batteries will be required to store that particular energy. Motors are required to run this particular wheels, power the wheels, wherein electricity will be taken, the motor will be running, and that torque will be supplied to the wheels. Nowadays we are talking of wheels having motor embedded in it. So here we have the motor inside this. Okay, and directly whenever we want a power, we will be supplying whenever we want to wheel to rotate, we will be supplying electricity to this particular motor. This particular motor will rotate and result in the rotation of this particular wheel. So electrical vehicle, in the electrical vehicles, we prefer to have a separate motor for every wheels, and this is the arrangement for that. Here we have a speed controller, which will again required in any electrical vehicle. So here it is shown how the system comes into picture. When the accelerator is given, the potentiometer comes into action, and correspondingly the amount of energy coming from the motor to the from the battery to the motor is being changed, and correspondingly we will be have the requirements met. These are the different designs of electrical vehicles, whatever we have nowadays. And the last, we are coming to end, where today we have reached from a mechanical vehicle to a smart vehicle, where so many systems, modern systems are being incorporated, and we are talking of nowadays of driverless vehicles, where we need to sit in the vehicle and tell the vehicle where we want to go, where is our destination, and the vehicle will take us to our destination and then park the vehicle, and then we will be coming out and doing our. So that is we are trying to move ahead. So we are purely from a pure mechanical, we are moving to very smart vehicles nowadays. And whenever we want to become an engineer of smart vehicles, we need to also become smart mechanical engineers. And with the expectation that you are going to become all smart engineers, uh, I I think the time is over, and we will finish off our lecture as on today. Uh, so, any doubt you can ask. I will stop recording first. Good day, sir.
Hello, sir.
May I
Yeah.
stop?
Yes, sir.
May I,
Yes, sir. Thank
may I
you, sir.
stop? Okay, thank you. Thanks a lot.
Okay, sir.
Any
Okay, sir.
any doubt student want to ask?